In this video, we will do some examples where we find probabilities and find boundaries on the normal bell curve. We will estimate probabilities using the empirical rule. We will look up probabilities in the z-score table, and using technology, we'll use norm.dist, where it's boundary, comma, mean, comma, standard deviation, comma, true for cumulative every time. And the last two approaches here are actually both employing the use of the normal cumulative distribution function, which finds cumulative areas for us under the bell curve. Recall the standard normal distribution is a normal distribution where the mean is 0, the standard deviation is 1, and this makes your x values into z-scores. Any non-standard normal distribution can be made into a standard normal distribution by passing the x-score values through the z-score formula. So this means that even if you're dealing with a distribution that is not standard normal, it's bell-shaped, but it's not standard with a mean of 0 and a standard deviation of 1, you can still use the z-score table by first converting your x boundary to a z-score. It's useful to keep the following in mind, that the left and right areas have to add up to 1, that the smaller area is always less than half of 1, and that the larger area is always greater than half of 1, right? So this has to do with the fact that the entire area under the curve has to be 1, and if you divide right down the middle, that would mean you had half or 0.5 area on each side. However, if you have a z-score that is to the left or to the right of the mean, that would mean that you have one area that's less than 0.5 and one area that's greater than 0.5. Also, if you know one area, you automatically know the other because you can just subtract from 1. Also notice that there's a mirror image happening here. The probability of a value that's less than -1 is 0.1587. Likewise, if you go over to +1 and you go greater than +1 on the right, that will have the same probability because they are mirror images. So let's find the probability of a value falling less than -1 on the standard normal distribution. Using the empirical rule, we learned that we expect about 68% to lie within one standard deviation of the mean. So in between -1 and 1, we should see an area of 0.68. So the remaining white regions would be 1 minus that, which would be 0.32. And since I only want the one left tail, I can divide that in half to get an approximate 0.16. So now let's use the normal cumulative distribution function to get a better answer. Now we can look it up in the z-score table. Just looking up -1, we will find the corresponding probability to be 0.1587. Let's take a look. Here's the negative z-score table. If I go to -1 here, I know that my answer is somewhere in this row. However, I have to line it up with the correct last digit of my z-score up here. And since it's just -1, my last digit would be 0, so I'll stay in that first column. And so my answer is 0.1587, which is close to 0.16. Sounds good. Now, let's also use technology. We're going to use Excel to do this. We'll do norm.dist, then we'll put in the -1. Well, let's actually do it. How about that? Okay, so we want the probability that z or x, if it's standard normal, you can use z or x interchangeably. If it's not standard, then you would use x. So let's use x because it's more general. So the probability that x is less than -1.00 on the standard normal distribution, norm.dist, the mean, or sorry, I need to put in the x value first, -1, comma, the mean of 0, comma, the standard deviation of 1, comma, true for cumulative. Now you can double click on true, or you can type the word true, or you can actually just put in 1, which means yes for cumulative. All right, so we see that we get the same answer we would have gotten from the table when you round it off. Now, what if you want to know the probability on the other side? Simply subtract from 1, and there you have your answer. What about finding the area to the left of negative 2.03? Again, we have a normal distribution with a mean of 0 and a standard deviation of 1, making this a z-score. So looking up in the table, negative 2 lined up with 0.03, I get my answer of 0.0212. Now let's use Excel to see if we get the same answer. So now my z-score has changed, negative 2.03. So I'm just going to change, and I get the same answer. Awesome. What about the probability of falling to the right of 2.03? Now, I could just use symmetry here because this area is exactly the same as the area I already found right here. So I still have that answer, and that's going to be equal to this. It's a mirror image. Now notice that if I try to use Excel to do this with positive, and I want to go to the right of positive 2.03, so two things changed here. I changed to greater instead of less, so it's going to be a right shaded region, and I changed from a negative to a positive. So if I put in norm.dist, then I put in positive 2.03 with my mean of 0, standard deviation of 1, and 1 for cumulative, notice that I get an answer that doesn't seem correct. And if I were to submit that as an answer, it'd be pretty silly because if I look at my image here, I see a very tiny shaded region, and this area is close to 1. So this would match up if I saw the left side shaded. So hopefully you'll notice that that must be the area to the left, and certainly it is. The norm.distribution function, the norm.dist in Excel, only gives you areas to the left of whatever value you give it. So we could simply take this and subtract from 1, 1 minus this, and you get the correct answer. Now, what about finding the area to the right? Well, we just saw that we could get that either by subtracting this little yellow tail away from the total area, and so we would get this answer, or we also saw that if we put in positive 2.03 and got the area to the left of that, it gave me the larger side. Now all this can be a little confusing, so the easier thing to do is just remember that one side's going to be greater than 0.5 and one side's going to be smaller than 0.5. Then go and use the z-score, and if it's a smaller area than you were expecting, then subtract it from 1. It should be bigger, so subtract it from 1, and vice versa. So here I'm being asked to find the probability of a value that's less than 1.27. That's a positive z-score. Now, I could look in the positive z-score table. So there's like a standard that everybody does in all the stats classes. There's a negative z-score table and there's a positive z-score table. And both z-score tables give you areas to the left of whatever boundary you give it. I don't use the positive side. I only use one side because I always just use symmetry and complements, and I like my students to learn that concept as well. So here's what I recommend. You have one table, you look up 1.27 in the negative z-score side, you get out this area of 0.1020. Looking at my picture, I can clearly see that that 0.020 belongs on the smaller side, and that to get my answer, I'm just going to need to subtract that from 1 to get my larger side, as shown here. Same thing with using Excel. If I do 1 minus norm.distribution with the negative z-score, I'm going to get that small area. and subtract it from 1 to get 0.8980. Now, with Excel, it's actually easier to just go ahead and use the original positive z-score because in this case, when you put it in, since you want a left-handed region, it's automatically going to give you the correct answer since it always gives you areas to the left. So in Excel, I would do the probability that x is less than positive 1.27. I can use my norm dot distribution with the regular 1.27, the mean of 0, the standard deviation of 1, and 1 for cumulative. And so there it'll automatically give me the larger region, 0.897, well, 0.98980 is what that will round to match up with your answer that you would get from the table.